In the year 2007, off the cold waters of Japan, a fisherman's net pulled something impossible from the deep. His hands trembled as he watched a creature writhing in his boat. It was 6 feet of nightmare-made flesh, a serpent, a dragon, something that should not exist. The body moved like an eel, sinuous and alien, but the mouth opened to reveal 300 needle-sharp teeth arranged in 25 perfect rows. Each tooth curved inward like a barbed hook, like the fangs of some prehistoric demon. The frilled gills rippling around its throat looked like the ruffled collar of an ancient beast dressed for ceremony. The fisherman called the local marine park, his voice barely steady. When scientists arrived, they knew immediately what they were looking at. This was a frilled shark, and it was dying. They rushed the creature to an aquarium tank, filming desperately as it swam in slow, anguished circles. For a few precious hours, humanity watched a living fossil move through water, its dark brown body undulating with the grace of something that had perfected its form 80 million years ago. Then, as if the surface world was simply too much for a creature built for eternal darkness, it died. The footage remains. 6 minutes of video showing us a window into the abyss, a glimpse of the deep ocean's most enduring mystery, the frilled shark, the dragon of the abyss, a predator that has survived virtually unchanged since the age of dinosaurs, lurking in pressurized darkness so complete that most life cannot even conceive of it. This is not a story about a shark. This is a story about time itself, about survival against impossible odds, about a creature so perfectly adapted to hell that it became immortal. Imagine the Earth 80 million years ago, the late Cretaceous period. Tyrannosaurus rex stalks the fern prairies of what will one day be North America. Triceratops graze in herds. Pterosaurs wheel through skies that have never known the roar of a jet engine. The continents are still drifting into their modern positions. The climate is warmer, the seas are higher, and deep below the sunlit surface of these ancient oceans, in the crushing darkness between 600 and 5,000 feet down, something hunts. It is long, slender, eel-like. Its body is built for gliding through liquid night. 6 pairs of frilled gills ripple around its throat like the elaborate collar of some Victorian monster. Its mouth sits at the very end of its snout, not tucked underneath like most sharks, giving it a lizard-like serpentine face that would inspire terror in any creature with eyes to see it. Inside that mouth, 300 teeth wait in perfect rows, each one split into 3 points like a miniature trident, each one angled backward to ensure that whatever enters this mouth can never, ever leave. This is the frilled shark, and in 80 million years, it will barely change at all. While the continents shift and collide, while the dinosaurs rise and fall, while entire oceans are born and die, the frilled shark endures. Fossil evidence shows that members of its family, the Chlamydosalicidae, existed even earlier, with teeth dating back to formations from the late Jurassic period, 150 million years ago. When the asteroid struck the Yucatan Peninsula 66 million years ago, ending the reign of the dinosaurs and killing off 75% of all species on Earth, the frilled shark survived. When the massive sharks of the Cretaceous went extinct, when the climate cooled and the ice ages came and went, when early humans first looked up at the stars and wondered what they were, the frilled shark remained, virtually unchanged, hunting in the same dark waters it had always known. Why? How does a species remain so static
while everything around it evolves, adapts, and often dies?
The answer lies in the environment itself. The deep sea is stable in a way that almost no other ecosystem on Earth can match. Down where the frilled shark lives, there are no seasons, no day or night. The temperature hovers just above freezing, unchanging across millennia. The pressure is crushing, ranging from 40 to 150 times the atmospheric pressure at sea level. Food is scarce, light is absent. For a creature adapted to these conditions, there is simply no evolutionary pressure to change. The deep ocean is brutal, yes, but it is predictably brutal. It has been the same for hundreds of millions of years, and in that stability, the frilled shark found its forever home. Scientists consider it a living fossil, though that term is somewhat misleading. The individual sharks you might encounter today are not ancient themselves, living perhaps only a few decades at most, though their exact lifespan remains unknown due to the difficulty of studying them. But their lineage is unbroken. The frilled shark you could theoretically encounter in the waters off Portugal or Japan or New Zealand is effectively identical to the one that hunted in Cretaceous seas. Fossil teeth from the genus Chlamydocelicus, found in deep-sea sediments, look nearly indistinguishable from the teeth of modern specimens. This is evolution in pause. This is time standing still. Imagine you are descending, not in a submarine, not with lights and instruments, but in pure experience. You leave the surface, the world of blue water and sunlight, and begin to sink. At 200 feet, the light begins to weaken. Colors fade. Red disappears first, filtered out by the water. Then orange, yellow. By 300 feet, even in clear tropical water, you are in a blue twilight. By 600 feet, the last trace of sunlight is gone. You have entered the midnight zone. This is where the frilled shark lives. The pressure here would kill an unprotected human in seconds. Your lungs would collapse, your skull would fracture. The weight of the water above you would crush your body into something unrecognizable. But for the frilled shark, this is normal. This is home. Its skeleton is barely calcified, mostly cartilage, flexible and light. Its enormous liver, taking up a significant portion of its body cavity, is filled with low-density oils and hydrocarbons that make the shark nearly neutrally buoyant. It does not need to swim constantly like many sharks do. It can hover, it can wait, and in the darkness, it waits like a coiled dragon. The body is extraordinary. Up to 6.5 feet long, sometimes more, it is smooth and serpentine with almost no fins along most of its length. The dorsal fin sits far back near the tail. The pectoral fins are small, rounded, paddle-like. The tail is long and ribbon-like, asymmetrical, more like an eel than a shark. The overall effect is of something not quite fish, not quite reptile, something ancient and unclassifiable. The color is a chocolate brown or dark gray, perfectly suited to blend into the perpetual night of the deep. But it is the head that arrests you. The snout is blunt and rounded. The mouth, as mentioned, sits at the terminal end rather than underneath, giving the creature a frontal, lizard-like appearance that is deeply unsettling. When the jaws open, they distend wide enough to swallow prey more than half the shark's own body length. The teeth, 300 of them, are arranged in 19 to 28 rows in the upper jaw and 21 to 29 in the lower. Each tooth is small individually, but together they form a forest of backward curving hooks. Once something enters that mouth, escape is geometrically impossible. Then there are the gills. 6 pairs of them, one more than almost any other shark. The first pair meets across the throat, creating a continuous slit from one side of the neck to the other. The edges are frilled, with gill filaments extending outward like decorative ruffles. This is where the shark gets its name. These gills are not just for show. They're incredibly efficient at extracting oxygen from water, an essential adaptation in the oxygen-poor depths where the frilled shark makes its home. The shark also possesses something called an open lateral line system. In most fish, the lateral line, the sensory organ that detects vibrations and movement in water, is enclosed in a canal beneath the skin. In the frilled shark, the mechanoreceptive hair cells are exposed directly to the surrounding water, sitting in grooves along the body. This is considered one of the most primitive configurations in sharks, and it may give the frilled shark heightened sensitivity to the faintest movements of prey in the darkness. In a world without light, vibration is everything. Imagine being a squid in the midnight zone. You are drifting through the black water, your bioluminescent organs glowing faintly. You are hunting tiny prey of your own, perhaps small shrimp or fish. The water is cold, just above freezing. The silence is absolute. There is no sound in the deep except for the occasional distant click of a hunting whale or the almost imperceptible movement of water currents. You have no reason to fear. You are built for this world. Your eyes are huge, adapted to gather every photon of bioluminescence. Your body is streamlined. You are fast. You are careful. And then you feel it. A vibration. Subtle. Almost nothing. But your instincts scream. You begin to move, your jet propulsion system firing water through your siphon. You accelerate, but it is already too late. From the darkness, the frilled shark strikes. According to scientists who have studied stomach contents and observed the limited footage of living specimens, the frilled shark is an ambush predator. It does not chase, it does not patrol, it waits. Its enormous liver keeps it neutrally buoyant, allowing it to hover in the water column without any effort. It may coil its body, using the posterior fins in its long tail for stability, positioning itself in the perfect strike posture. Then, when prey approaches, when the lateral line detects movement, the shark executes a strike so fast and so precise that it seems almost supernatural. The body uncoils. The shark lunges forward like a serpent, bending its flexible spine and propelling itself with shocking speed. The mouth opens impossibly wide. The jaws, articulated directly to the skull in a primitive configuration called amphistyle, extend forward, and then they close. The 300 trident teeth snag the soft flesh of the squid, the backward curve ensuring that every attempt to escape only drives the prey deeper into the trap. The shark may close its gill slits during the strike, creating a suction effect that pulls the prey into its mouth. Then, using its long, flexible jaws, it swallows, whole. The squid disappears into the darkness of the shark's stomach, where powerful acids will break it down over the course of days.
Squid comprise about 60% of the frilled shark's diet, but they are not the only prey. Stomach content analysis has revealed remains of deep-sea bony fish, other sharks, and even fast-swimming oceanic squid species that spend time in shallower waters, suggesting that the frilled shark sometimes migrates vertically, rising closer to the surface at night to hunt in the richer waters of the mesopelagic zone. This behavior, called diel vertical migration, is common among deep-sea predators. It allows them to exploit the greater abundance of prey near the surface while avoiding the dangers of daytime hunting in well-lit waters. The frilled shark is not a fast swimmer in the traditional sense. It is built for efficiency, not speed. But when it strikes, the concentrated explosion of motion is devastating. Researchers believe the shark can brace its rear fins against the water, using leverage to amplify the force of its lunge. Imagine a compressed spring releasing. That is the frilled shark's strike. Fast, brutal, final.
Reproduction in the frilled shark is one of the most astonishing aspects of its biology, and it may represent an extreme adaptation to the scarcity and unpredictability of the deep-sea environment. The frilled shark is ovoviviparous, meaning the eggs hatch inside the mother's body. The embryos develop in egg capsules within the uterus, nourished by yolk. There is no placental connection, no umbilical cord. The young are entirely self-sufficient within their eggs until they are ready to be born. But here is the extraordinary part. The gestation period of the frilled shark is estimated to be up to 42 months, 3.5 years. If this estimate is accurate, it would be the longest gestation period of any vertebrate on Earth, far surpassing the 22 months of an African elephant. Why would evolution favor such an absurdly long pregnancy? The answer, again, lies in the environment. Food in the deep sea is scarce. Producing offspring is an enormous energetic investment. By extending the gestation period, the mother can time the birth of her pups to coincide with periods of greater food availability, or simply ensure that the pups are as developed and capable as possible before they enter the brutal world of the abyss. A frilled shark pup is born at about 16 to 24 inches long, fully formed and ready to hunt. The average litter size is 6 pups, though it can range from 2 to 15. The frilled shark lives alone. It does not form schools. It does not cooperate. It drifts through the dark in absolute isolation, encountering others of its kind perhaps only once every few years, and then only to mate. Imagine that existence. 80% of your life spent in total darkness, surrounded by crushing pressure, in near freezing water, with no companion, no pack, no family, just you and the void. This is the life of the frilled shark. This is how it has lived for 80 million years. Humans have known about the frilled shark scientifically since 1884, when the zoologist Samuel Garman described a specimen caught in Sagami Bay, Japan. He named it Chlamydocelicus anguineus, from the Greek words for frill and shark, and the Latin for eel-like. But for over a century after that initial description, the frilled shark remained largely a mystery. Specimens were occasionally caught as bycatch in deep-sea trawls or on long lines meant for other species, but sightings of living individuals were almost non-existent. The shark was a ghost, a legend whispered about in marine biology departments, but never truly seen.
Then, in 2004, everything changed. Marine biologists operating a remotely operated vehicle in the Blake Plateau off the southeastern coast of the United States descended to a depth of 2,866 feet. The cameras were rolling, scanning the dark seafloor, when something moved in front of the lens. It was a frilled shark, alive, swimming, the first time the species had ever been filmed in its natural habitat. The footage was grainy, shot in near total darkness with only the ROV's lights for illumination, but it was unmistakable. The long serpentine body, the frilled gills, the lizard-like head. For a few precious seconds, humanity watched a living relic of the Cretaceous glide through water that no human will ever visit without mechanical assistance. 3 years later came the Japanese capture, the fisherman and the dying shark in the aquarium tank. That 6-minute video became one of the most viewed pieces of deep-sea footage in history. People could not look away. There was something hypnotic about the creature, something deeply unsettling and yet beautiful. It moved with a grace that seemed almost deliberate, as if it knew it was being watched, as if it was performing one last time before returning to the abyss forever.
Since then, there have been other sightings. In 2014, a trawler near Lake's Entrance in Victoria, Australia, pulled up a 5-foot frilled shark from depths of over 3,000 feet. The fisherman, Simon Bogue, told reporters it looked like something from another time. He was right. In 2017, another specimen was caught off the coast of Portugal,
part of a European Union research project studying bycatch in commercial fisheries. The researchers were stunned. They had been expecting to catalog common deep-sea species. Instead, they found a dragon. Every capture, every sighting adds to our understanding, but the frilled shark remains fundamentally enigmatic. We do not know how many exist. Population estimates are impossible, given the vastness of the deep ocean and the rarity of encounters. We do not know their exact lifespan, though estimates suggest they may live for 25 years or more. We do not know the full extent of their range, though they have been found in scattered populations across the Atlantic, Pacific, and possibly the Indian Ocean, from the waters off Norway to New Zealand, from California to Chile. We do not even know for certain how they hunt, relying instead on inference from stomach contents and brief observations of captive or dying individuals.
The dragon is still down there, in the crushing darkness, in the freezing water, in the eternal night. It is waiting, hunting, surviving, as it has always done, as it will always do. And when we finally destroy ourselves, when our cities crumble and our civilizations fade, when the surface of the ocean reclaims the land and the forests grow over our ruins, the frilled shark will still be there, hovering in the abyss, unchanged, eternal, perfect. Somewhere, right now, at this very moment, a frilled shark is striking. A mouth is opening, teeth are closing, prey is being consumed. The cycle continues, the lineage endures, and in the deep, in the dark, in the cold, the dragon of the abyss survives.
If you enjoyed this breakdown or have ideas for future videos, feel free to comment and subscribe my channel.